Okay, let's go a little bit more. So just now, we have seen what MAD can do. MAD equal to sum of demand and forecast error divided by the total amount of the period. Yeah. Now we learn another one. It's called MAPD, mean absolute percent derivation. This one add another word called percent. Okay. MAPD equal to sum of demand and forecast. Still same, you're still seeing the two goalposts or absolute value there. But now the denominator changed a little bit. The denominator changed to sum of the demand rather than the period just now. Huh? So MAD is N is total numbers of period, but MAPD is the absolute error in the percentage of demand. So that's why denominator become total demand. Okay, copy this equation. We're going to look at one tutorial question using this MAPD. So again, we're going to use tutorial number 7 for alpha 0.3 again, just to see what does this MAPD can give you. Huh? So MAPD again give you equal to total absolute error divided by total demand. Huh? So let's say if you take example tutorial number 7, the MAPD, you take the absolute value 53.38 divided by 377. What does it mean? Okay, I just roll back a little bit. Huh? I project the big table. Okay, here. So MAD is take these numbers divided by time, the total period you have. Here is 11, huh? Because here is only 11 numbers you have here, right? So for MAPD, what you have, you take the total demand divided, total difference of your error, absolute error, divided by total demand. You get percentage in the percentage of demand. Huh? So MAD just a ratio. However, when it comes to MAPD, you take error divided by total demand, become the percentage of demand. Go back to the slides. Huh? So here, MAPD for alpha 0.3, you'll get 53.38 divided by 577. You'll get a value 0.069. You get if you use calculator to calculate, you get 0.096. What does it mean? It means that you move 2 decimal behind, you become percentage. 0.096 or 9.6%. Huh? This one, 9.6% of what? Of your total demand. Okay, meaning if you use exponential smoothing forecast, the error percentage in terms of total demand, it will be about 10% of your total demands that every time you forecast, there will be about 9.6% or very near to 10% of error. All right. Let's say the total demand is 100. There will be 10 plus minus 10 error in your forecastings. Okay. It just means that way. Huh? All right. So MAPD, it will focus more on the total demand number percentage. Right? Okay. So again, we want to lower the percentage as much as we can, or choose the lowest one will give you the most accurate one. Huh? Again, we don't have a perfect 100% accurate model, but we try to give the lowest MAD or MAPD numbers. In this case, we have seen one numbers for MAPD, alpha 0.3 for exponential smoothing forecast. And just as a comparison, I give you all these numbers. So alpha 0.3, just now we calculate 9.6. If you do the same for alpha 0.5 for exponential smoothing, I'm sorry, typo error here. It's not MAD, MAPD because I copy from the previous slides. There's a typo error here. It's a MAPD. This one MAPD. This one also MAPD. Typo error here. So for 0.5, MAPD is 7.9%. For adjusted exponential, MAPD, again a typo error, MAPD is 7.5%. Linear trend, MAPD become 4.9%. So you can see here from 9.6 drop to 4.9%. So in here, we can say that linear trend line give you the most accurate compared to the other methods. Yeah. Any question on the meanings of MAPD? Maybe you want to copy the percentage just for your homework or for your revision. Okay, 0.96 for alpha 0.3, 0.79% for 0.5, 0.75 for adjusted exponential smoothing, and 4.9% for linear trend line. Typo error is not MAD but MAPD for all these values. Okay. Once, just now we talked about MAD, MAPD. Now we talk about accumulative error. What does accumulative error means? Is a total add up of the forecast error. Okay? It just means that you add all the small error together. You add all the error together. Not the absolute one, not the goalpost one, but you go for the difference between the forecast and real data. You add all the column together like this one. You add all the column. You want to find all, this is your accumulated error. Okay. So again, just look back at the table for 0.3. Your accumulated error is 4.92, which is I asked you to copy just now. Just below this column is 949.32. Okay, so don't confuse cumulative error and this absolute error here. There's a different meanings there. Okay. Okay, I just highlight here. So you just need to fill in this one in your tutorial handouts. Cumulative error is a sum of forecast error, and the equation is capital E, sum of E individual total, right? I mean the individual error here, you total, get one number here. Okay. Then the rest, I give you a reference number for other methods also. So for alpha 0.3, you get 49.32. If you do the same calculation for alpha 0.5, you get 33.21. If you do adjusted exponential smoothing, alpha beta, your cumulative error 21.14. And linear trend line, if you do linear trend line, I put a bracket there, is almost near to 0. Okay, it's almost near to 0. Yeah, this one you can observe from the line. Huh? If you look at this data, if you look at this data, and you do the normal linear trend line, you will get the cumulative error here. Yeah, there are some value, there are some positive value here, but it's very, very small. So you can say it's very near to 0. Okay, copy 49.32, 33.21, 21.14, and this one, you can use the curly sign near to 0. So what does this cumulative error mean in the management subject or management discipline? Is an average error, or we call it bias, right? How good is your estimate, right? So average error, this one I think you need to fill in your tutorial handouts. Average error is, sorry, yeah, this one is the period average of cumulative error, not pre-period. It's a period average of cumulative error. So the equation for average error, capital E with a hyphen, capital E with a straight line above, equal to total error that you calculate from the table divided by total of time. Okay. So for example, if you use the same table for alpha 0.3, the average error, the cumulative error is 49.32, but the bias or the average error, you take 49.32 divided by the months of your forecast. You have 11 months here. Okay, so 11 months divided by, okay, 49.32 divided 11, you get about 4.48. Okay, so you learn a few technical words for management: cumulative error, average error. This is just a summary of what we learned so far. So you have the forecast a few methods. You have learned exponential smoothing. You have learned adjusted method. You have learned linear trend. So MAD, MAPD, cumulative error, and average error. So for trend line, you also don't have average because it's near to 0. Okay. All right. The next one we call it regression method. This one also popular in Excel if you use Excel to plot graph. And this regression method also another way to tell you how close is your forecast line or trend line to your real data. Okay, you need this value when you do your FYP, especially you do data collecting, you do measurement for your FYP. If you have a statistic data or you have a engineering data, one information we'll look in your report is regression, right? How good is your data? How good is your trend line? Okay, because when you in the engineering, when you do measurement, you have the distribution of data there. So from Excel, you can plot trend line, and then from the trend line, you can see the regression, how good it is, right? So in all the journals paper published, normally you will see regression value at the top of the graph, right? Okay, so linear regression, just now you see in linear equation, y equal to a plus bx. This is a linear equation. So to develop the equation, you have seen this equation before, right? You have seen this equation before for linear trend method. A equal to this one, B equal to this one, average this one, average this one, x, y. You substitute the value, you get your A and B. Okay. Let's practice regression method with tutorial number 8. is a new set of data. Okay, it's a new set of data. So you have a data here. What does this data means? The university actually collecting the data according to their football teams, according to their attendance of their audience. For example, this first time they collect is when they have an audience of 36,000, they win 4 times. So the next season they will not season, but the next time they have a tournament, the audience is 40, they win six games, right, and so on. So if the audience next one they collect total or audience, how many they wins and so on. So they need to use this data to ask for budget for their sponsorship, right? So develop budget for coming years, forecast football attendance. Because based on attendance, maybe they can sell some side products, t-shirt, balloon, and so on. So they can make money from that. Maybe they have ice cream stalls, pizza, beers, and so on. So football attendance account for the large portion of its revenue, so and so. Okay. The business manager has accumulated a total annual average attendance for the past 8 years. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 years. So these are 8 data for the past 8 years. And it can consider as a good start to do forecastings. Given the numbers of returning starters and strength of the schedule, the ALEC director believed that the team will win at least 7 games next year. So the game manager or the team manager estimate next year. So next year is number 9, right? So you have 1, 2, 3, 4, 5, 6, 7, 8. The manager or the game or director estimate they're going to win 7 games next year. Develop a simple regression equation for this data to forecast attendance for the level of success. Mean we use the 8 years data to forecast the next year attendance if you want to win 7 games next year. How many attendance that you focus on? It's like estimate what will be the audience will be in the hall or in the hall. So you have all this information in your handout already. So I pull this data to the left, and it asks, and I just remove all the unnecessary information, and I just put in the information important instruction. So you need to develop a simple regression formula just now. Y equal to a plus bx just now. So what you do, you transfer the information, the raw data that you see on your tutorial handouts, convert into the form of this one. I think I also give you this table templates to save your time, so you can follow along. So you convert the raw data into this one. Of course, in your test and final exam, you won't see these templates. I won't give you, right? I will give you raw data. You need to use the correct method to do forecastings. All right. So you have your X, you have your Y. How you decide your X? Your X actually is your X-axis of your graph. Y is your Y-axis of graph, attendance. So you need to estimate your attendance, right? So your attendance become your Y. Because the equation Y equal to A plus BX, you want to find your Y, you start from your X. You already know your X. Your X is 7 next year, 7 games next year. So that's why you formulate your table. Your X is your win, means your win numbers. Your Y is your attendance. Again, be careful. This one is in thousands. This one is in thousand. So when you build table, you can simplify it, become a small number. You don't need to repeat all the zero behind. So you just simplify from the table, this one into this one. Okay, copy 436,300 become 3.6 and so on. So you have the equation to build the y equal to ax plus b. You have the a equation, b equation. Right, so you calculate what is your x, what is your total x, what is your total y, what is your xy, what is your total xy, what is your x square for each one of the data, what is the total x square, find the mean average value for x, x bar, same with xy, a lot of work here. Then you use the equation. I'll treat that as your homework. Huh? So you just need to copy the red color numbers just to follow along. 49, 346.9, 2167.7, 311 for your x bar total, x square total. Okay, put all this. This one you can copy later. All right. Important is 49. This number, this number, this number. Okay. Yeah, 49, 346.9, 2167.7, and 311. Then I'll pull this table to the left-hand side of my screen. You start calculation using this equation, y equal to a plus bx. Calculate your a, calculate your b using the value that you just calculated just now. All right. So your x bar equal to 6 point something, y average equal to 3.36. So your b, you calculate, you substitute the value inside there. So your b will be 4.06. So your a value will be 18.46. Okay, important you understand the method. All the values will change in text in the test or final exam. So important you understand what is y equal to a plus bx, how you find the a, how you find the b. Formula won't be given in test and exam for your info. Okay, once you have your all these values, substitute inside there. You have a, b, so substitute inside here. So you want to find the next number, right? The next year, right? The forecast attendance for 7 wins. In this one is 7 wins because the x is the number of win, right? In your equation just now, in your equation, your x, this one, the x, the y-axis, the x-axis is your number of win. Now it's not number of years, but it's number of win here. So your x, the coach already estimate next year they can win 7 games. So you substitute x over here to forecast the total attendance for your y. Okay, substitute 7. Y is 46.88, and again, this is not a 2 decimal place number. You already simplified 1000 in your data here, right? Remember to switch back into 1000. This one means if you want to win 7 games next year, you are estimating the audience of 46.8 thousand audience. Okay, 4688,000. Means move 3 place behind. Okay, any question for getting the numbers? Any question? I hope it's clear for everyone. Yeah. Okay. So I put the AB equation here, x over the general equation over here, and if you plot the graph, if you plot the graph from the data, y-axis is your attendance, x-axis is your wins, you plot the line over here. Just so for your info, your assignment will be coming. You need to generate something like this in your assignment. Yeah. Okay. And individual, let's see how. Let's see how. In most of my assignment, it will be when they come to calculation, you will get a unique number for individual student. Meaning I will ask you to calculate your y value, x value based on your matrix number. So every one of you will come up with a very unique number. You will generate different graph in your class. All right. So no point you copying your friend. You copy your friend means you get the wrong answer because you have your own set of data. Okay. So this will coming in your assignment, coming assignment. Yeah. Right. So when you do your line using the y equal to ax plus a plus bx, right? You can plot the graph, the estimate graph. So if you want to know how many wins you need, you just key in the x value in the equation. Huh? You just key in the x value here. Then you know how many audience that you are coming. Huh? Okay. Now in this case, why I'm showing you using linear trend line? Because from the previous error, MAD, MAPD, linear showing the best focus method among all. So that's why I'm using the regression line, a trend line here. Huh? Okay. The next one, let's see the time. Okay. Okay, a few more slides. Huh? Next one, learn about a technical word called correlation. Correlation, the keyword here is relationship. Relationship between two parameters that you key in or three parameters that you key in. Correlation, it just means that the relationship between the variables, right? They give you this equation. Take some time to copy. Correlation also is one of the built-in calculation in Excel. When you plot a graph in your FYP later on, this one also will help you to tell the story between the parameters that you investigate. R correlation equal to n sum of xy minus sum of x multiplied by sum of y divide by square root of n multiplied by sum of x squared minus sum of x square multiply by the y component. And the value of your R always fall within positive 1 and minus 1. Okay, your R value will fall within positive 1 and negative 1. This value is important, especially when it comes to your FYP, you are doing experiment, especially there's any measurement in your FYP. This will be one of the important value that you should report in your project's report. So since you have the range of correlation, negative and positive, so value of positive 1 indicating a strong linear relationship between the variable. Means if you add the positive sides, means if you have a positive 1 value or towards positive value, it means that they are relationship between the A and B. If we have a negative, means there are no relationship at all. Means that if A do something, B doesn't react. If your R value go towards negative. If the R value go towards positive, it means that whatever A do, B will react to it. Okay. So if you do the tutorial number 8, if you use this equation to calculate tutorial number 8, the R value will be 0.947. This is positive value. What does it mean? It means the variable in tutorial number 8, A, B, or numbers of demand and the years and so on, is related with each other, right? So if you get positive value towards 1, it means you have a strong relationship. You are tied together. It means they will react to each other. A do something, B will react. Right? If you get a negative, means A do something, B may be not responding. Right? So there's no trend between A and B. Right? Okay, so this one you can read. So it means that the number of wins in tutorial 8 just now, because this one is near to 1, it means that the numbers of win is having strong relationship with the number of audience. Means if you want your team to win in the match, you invite more and more crowd to the audience and then shout for the name of the teams. Right, team A, team A, team A, then team A will win. Right, this is based on mathematics estimation. Right? The section to the mathematics value you use to persuade your management for sponsorship is this value. And if you do research, correlation coefficient will tell you how confident it is between the two parameters that you choose to investigate. Another one is coefficient of determination. Is a percentage in percentage. This one is in ratio. Another one is percentage. Is the R square. If you R square, you'll get percentage. So if you want to change correlation into coefficient of determination, another meaning of correlation means in percentage. So correlation determination given by R square means once you get your R square, you become coefficient of determination. If you take the example number 8 or tutorial number 8, you square this value, you get 0.897 or 98.7%. Meaning A do something, it will affect B almost 90%. Means A and B will react to each other. Okay, if you see as a chemical reaction, then it will be more easier to understand. A do something, B will react, or B do something, A will react if you have a very high percentage. Okay, so there's a difference between correlation and coefficient of determination. One is percentage, one is ratio. Okay, the rest you can read. Okay, with this we conclude chapter 4 and we will start chapter 5 next lecture. Okay, end the recording.